This lesson is over triangle inequality in the Pythagorean theorem. Objective students will use the Pythagorean theorem to find the area of triangles, find what side lengths could be a triangle, and what types of triangle they could make. So before we start, make sure you know the area of the triangle, the formula for that. It is 1/2 base times height. A couple other ways you could write it: base times height divided by 2, the same thing. Or obviously the 1/2 you could write as a decimal. If you're going to use a calculator, I would type it in as 0.5. But we're mainly going to say 1/2 base times height, but any of those will work. So find the area of the following triangle. So the area of the triangle, we have the base is here and the height is here, but we don't know the height. So it would be 1/2, the base is 9, and the height we don't know is h. So we have to find h. Well, the good news is we know that it's a right triangle, and so we can use the Pythagorean theorem. So Pythagorean theorem, 9 squared plus h squared is equal to 12 squared, which is 81, plus h squared is equal to 144. Then subtract 81 from both sides. H squared is equal to 63. And then take the square root of both sides. H is equal to, the square root of 63 is 7.9372. Again, I'm going to stick with the normal theme. If you round to 7.9, that's fine. Or what I would do is I always use 2 decimal places, 7.94. It doesn't make any difference whichever one you want to do. But since they didn't specify to round to 1 or 2 decimal places, I usually go with 2. But again, I'll accept either answer. Now, here's the thing with this one. This is, I would say, the hardest part, and it's not difficult. It's just hard to remember. That's not your answer. I know there are a lot of you guys that you're going to put that as your answer. You're going to feel good about yourself. You're going to move on. Well, you're close, and you're going to get partial credit for that, definitely, for sure. But they're not asking for this height. They're not asking for that side length. They want the area. So we need to take that h now and plug it back into our formula. So that is 1/2 times 9 times 7.94, or again, 7.9 is fine. And then I would just type that in my calculator, and personally, I would type it in using this 0.05, just because that's easier to type in a calculator. So 0.5 times 9 times 7.94. The area is 35.73. Technically, that would be inches squared, but again, I'm not going to worry too much about that. Since it's area, it's got to be squared, and I'm not really going to go into that whole details on that. So this next one is a little bit more difficult, and this is what I need to make sure you pay attention to. So this one, area is equal to 1/2. The base is 18. We don't know what the height is. We have to find the height. But the thing that makes this one harder is if you try to use the Pythagorean theorem, this 18 is not the length you're going to use, because the 18 is the base of the whole triangle, but the whole triangle is not a right triangle. So we only need to look at half of it. Since this is perpendicular, we're just going to look at 1/2 of the triangle. It doesn't matter which one. Now, there's a really long story with this where this is an isosceles triangle. These are both 12 inches, so it's isosceles. If you have a perpendicular bisector, or if it goes through the vertex or isosceles triangle, that means it actually bisects your base. Now, that's a really long explanation. The biggest thing I need you to remember is if it's isosceles triangle, this perpendicular bisects that. So the 18 is the whole thing. This part is 9. This part is 9. So now, when you look at that triangle, now we can work with that. So we have 9 squared is 9 squared plus h squared is equal to 12 squared. 9 squared is 81 plus h squared is equal to 144. That's what the last one was. Huh. So ironically enough, this is the exact same thing we just did. I did not realize that, but that is okay. We're too far gone. 144 minus 81 is 63. And when you take the square root of both sides, you end up getting h is equal to, again, you could either put 7.9 or 7.94, whichever way you want to round is fine. Then that is our h, but now this is where it is different. You're not going to get the exact same answer because it did have the exact same height, and it did have this 9 was the same and the 12 was the same. But you have to realize now, when we're going back to this part of the formula, now we're using that whole base again, because the only reason we used 9 was to find our height. Now that we have found our height, our base is 18, our height is 7.94. That's one of the reasons I like to set up the formula first. That's 1/2 times 18 times 7.94. And again, if I were you, I would just type that in my calculator. 0.5 times 18 times 7.94. Okay, hold on. Didn't type it in right. That ends up giving us 71.46. And again, technically that's inches squared, but you don't need to worry about the inches squared. Don't even think about it. 71.46 is fine. And again, if you want to round that to 1 decimal and put 71.5, I can live with that. So this is going to be the same thing. The only difference is it's flipped upside down. So this 14 can be cut in half. Again, it's because these are an isosceles triangle. These sides are both 9. So that means this is 7. So now same thing. We have 7 squared plus, we call that x because they don't give us 1. Or if you want to call it h, that's not a bad idea. Because again, I know it's flipped upside down, but we still want to think of the 14 as the base and that x is the height. It's equal to 9 squared. So that's 49 plus x squared is equal to 81. Subtract 49. We get x squared is equal to 81 minus 49 is 32. And square root both sides. The square root of 32 is 5.6568. So again, if you want to put 5.7 or 5.66, either one will work. I personally, again, since they don't specify, I always go to 2 decimal places. So my area is 1/2. Now remember, the base is not 7. The base is the whole thing is 14. And the height we found was 5.66. Again, if you want to use 5.7, that's fine. And then just type that in your calculator. 0.5 times 14 times 5.66. Oh, keep hitting minus, sorry. $39.62. Should be centimeters squared, but again, I'm not going to worry too much about that or explain too much of why it's squared. So you could also look at this as an in story problem type form. A roof truss is an isosceles triangle made of wood. Several of them are lined up in a row to hold up that's supposed to say roof, not room. Okay. If the base of the truss in my house is 42 feet long, so the base is 42 feet, the piece of wood that makes up the side of my roof are 30 feet. That's 30 and 30. How much area does one truss make up? So this is the same thing we did. This is isosceles triangle. So if this is 42, that means each of these is 21. So we have 21 squared plus x squared is equal to 30 squared. We'll get some bigger numbers for this, but that's fine. 441 plus x squared is equal to 30 squared, I think, is 900. Yes, 900. Subtract 441. 900 minus 441 is 459. And get the square root of those. Square root of 459 is 21.424. I'm going to round to 2 decimal places. Again, you don't have to. You can go to 1. That's okay. But that's just this height right here. So now the final area. We have area is 1/2. My base is 42. My height is 21.42. 0.5 times 42 times 21.42 is 449.82 is the area for that one, which I think would be a really tall roof, but that's okay. Disproportionately tall, but that's okay. So the next thing we have is this theorem where the triangle inequality theorem. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what this is saying is you are able to look at three side lengths and you can tell if it could possibly be a triangle or if there's no way it could be a triangle. Now, they make it more complicated. They say if you take AB plus BC, so AB plus BC, that has to be bigger than AC. That has to be bigger than this one. But then they do that with all of them. AC plus BC also has to be bigger than AB. AB plus AC also has to be bigger than BC. So that is true, but we can make it a little bit easier by looking at it this way. When you add the two short sides together, it's got to be bigger than the longer side. So rather than doing all three of those, all you have to do is find the two shorter sides, add them together, and that has to be bigger than the longer side. And if you think about it, it makes sense. So if we have this isosceles triangle, just for an example, the base is 8, these sides are 7. Well, if we make them 6, that's fine. 6 plus 6 is bigger than 8, that's fine. 4.5, 4.5, that's 9, that's bigger than 8, that's okay. But what if we made one side length is 3, the other side length is 5? Well, that does equal 8. Well, those would be flat. Those couldn't go up any at all. So those two shorter sides have to add up to be bigger than the longest side, is what I was trying to show with that. So once you know that, it's actually really easy. Just look at these, especially these. A lot of them, they put them in order. I guess, well, maybe not. Some of them they do. Your two shorter sides are 4 and 3. So 3 plus 4 is 7. 7 is bigger than 5, so that one could be a triangle. This one, my two lengths are 13 and 5. That equals 18. 18 is not bigger than 18. It's the same. If it was equal to, then we'd be good to go, but it does not include that. If you look back, none of them include that. It's got to be bigger than, so this does not work, so this would not be a triangle. And again, if you can imagine this, one side length would be 5, the other side length would be 13. That'd be the exact length as the base, and it couldn't go up or down at all. And we have 4 and 5. 5 plus 4 plus 5 is 9. 9 is bigger than 8, so that one could be a triangle. So yes, triangle. That's all there is to it. Take your two smaller sides, add those together. If they're bigger than the biggest side, then you're good to go. And they've got to be bigger. They can't be equal. Now, the next thing you can tell is you can tell what type of triangle it is, and we're going to use the Pythagorean theorem for this. Now, if it's a right triangle, we already talked about it. A squared plus b squared equals c squared. Now, I apologize for this because for these two other ones, I'm going to take the c squared, I'm moving it on the other side of your equation, so it's going to be c squared is equal to a squared plus b squared. And the reason for that is I think it makes a little bit more sense when you think about it. Because if you do the Pythagorean theorem, if it's exactly equal, it is a right triangle. But if you do the Pythagorean theorem and it's not a right triangle, then it's either going to be smaller than or bigger than. And I think it helps me remember that the c squared, if it's smaller, it's an acute triangle. And that's why I put the c first. If you put the c after this one, then all of a sudden it is, if a squared plus b squared is bigger than c squared, then it's acute. But with the word acute, you think smaller, and so you think less than, and so I think it gets confusing. So just always remember, always start with your longest side. If your longest side is less than, it's going to be an acute triangle. If your longest side is bigger than, it's an obtuse triangle. And again, when I say bigger than, it's using Pythagorean theorem. So your longest side squared, if that's smaller than, your two shorter sides squared added together. If your longest side is squared, is bigger than the sum of the squares of the two shorter sides. So we're going to combine those two things. A is decide if the three numbers can represent the sides of a triangle, yes or no. And if yes, is it obtuse, right, or acute? So we have 3, 2, 4. So 3 plus 2 is equal to 5. 5 is bigger than 4, so yes, this could be a triangle. So for A is yes. What type of triangle? Is it a right triangle? Is it an obtuse triangle? Is it acute? Well, this is where, again, you're going to start with your longest side. Always start with that, 4 squared. And then I'm going to leave kind of a blank space here. and then I'm going to have 3 squared plus 2 squared. And the reason it's blank is because I don't know, it could be equal, it could be less than, it could be greater than. I'm not sure, so I'm just going to kind of leave this blank spot. 4 squared is 16, 3 squared is 9, 2 squared is 4. So 9 plus 4 is 13, so is 16 bigger than or less than 13? 16 is bigger than 13, so that means 4 squared is bigger than 3 squared plus 2 squared, which means c squared is bigger than a squared plus b squared. And if we look back, if it's bigger than, it's obtuse. And again, that's what I was talking about before, where since we write it that way, since we start with the longer side, I think it's easier to remember, because if it's greater than, it's obtuse. So B, this is an obtuse triangle. And that's all there is to this. Don't make this harder than it is. 9, we have 1 plus 2 is 3. 3 is not bigger than 5. So this one, A, is no. Since it's no, we can't even go on to B, because it can't be, it's not obtuse, right, or acute, because it's not a triangle. Again, if you take those two smaller sides and add those together, they've got to be bigger than that third side. Now, again, for this one, again, you're just adding, you don't square anything. You wait to do obtuse, right, acute. You wait to square them until that part B. Let's try this one. We have 5 plus 7. That is equal to 12. Again, 12 is not bigger than 12. It's equal to 12, but it's not bigger. So again, for A, this one is no, it's not a triangle. The two shorter sides added together are equal to the longer side, but they can't be equal. It's got to be bigger than. And this one we have 11 plus 15. This one's pretty obvious. It's going to be a triangle, but that's going to be 26. 26 is bigger than 16. So for A, that is yes, it is a triangle. But then C squared, then we have A squared plus B squared. I should have written it like that the first time. Is C squared, the longer side, is it bigger than or smaller than? Well, 16 squared. Then we have A squared plus 15 squared. 16 squared is 256. 11 squared is 121. I think 15 squared is 225. But again, if you're not sure, definitely check. Even if you think you're sure, I would check. 121 plus 225 is 346. So 256, the longer side, is smaller. The longer side squared is smaller than two shorter sides squared. So this B, that means it is acute. When you square the longer side, if it's smaller than the other ones, the other two sides squared and added together, it's got to be acute. And I didn't have one, but again, obviously, if you got done with this and you ended up with like 256 and 256, if they're equal to each other, then they are a right triangle. So that's that example. So if you have any questions, let me know. The good news with this is that you could very easily make up your own problems and just pick 3 numbers and see what happens. This is doesn't happen a lot in math and high school math, but this is one that it's really easy to come up with problems for. And again, if you have any questions, make sure you let me know. Thank you. Thank you.